So as we were talking of this codomain. Okay, so I was saying that the domain can be called as input and codomain can be called as output. Okay, so functions is a too interesting topic, and to define function we can give a much longer speech. So for that we should know much about functions. Functions, first, in normal life we know that function. What is function? We perform a function. The function of that machine is that, this and that. The function of that box is to store some food, and like that we we have function of everything. Okay, that is the function in real life. Function in this in these sets, in this ordered pairs, is what is this function? In simple words, we can say that if we add, subtract, multiply, divide, and raise to the powers are multiplication, so I don't count it as anything else. Power function, any type of function. Like if we are now I am changing this example. If the domain is 1, 2, 3, and the codomain is for example 1, 8, and 27, and 64 and 125, then we can have a function from set A to A. Okay, from set A to A, there's a function from 1 to 1. The function would be fx equal to x cube, and fx can be written as y. So y equal to x cube. Okay, so as we are able to see, 1 cube is 1, 2 cube is 8, 3 cube is 27. So 1, 1, 2, 8, 3, 27. This is a simple function. But what about this 64 and what about this 125? So we call it that 1, 8 and 27 is the range. Okay, the range, in simple words, what is range? Range is the image of range has a p-image in the domain. Okay, that's range in simple words. Now what about 64 and 125? We can simply say that these are elements of codomain and these are simply here. Okay, and when these elements are not present, if there is only 1, 8 and 27, when range and codomain have equal number of elements, then it should be onto. Now there are two terms also. We call it as objective. Now you talk objective and subjective. Now what is objective and what is subjective? This is the most important topic here, objective and subjective. So here, if in objective and subjective we are talking about is what we talk is that in this simple range set B, okay, if this range 1, 1 is, we know that in functions definition only it says that it should have a unique image in the domain. Okay, so that was very simple. Codomain, it should have a unique image in the codomain. Okay, so now we are talking about 1, 1 and onto. Now what is 1, 1 and what is onto? That is our main topic. Okay, so 1, 1 says that if a given function is 1, 1, meaning that if I take here 1, 2, 3, 1, 8, 27. Okay, if I am taking this example, then it's bijective. Bijective meaning 1, 1 and onto both, meaning it's subjective and objective both. Okay, onto is when range. Simply we can say onto is when range is equal to the codomain. Okay, codomain of y, codomain, or we can say range. Range is simply codomain. When range is equal to codomain, it's not necessary that range would be codomain. But if range is codomain, if it is given that range and codomain have equal number of elements, then it is onto. onto, meaning that it can be possible that two elements are 1. Okay, so that's onto. Now 1 1 1 means that for in the Y, 8 should have only one image in pre-image in the domain. Okay, 8 should have only one pre-image in the domain, meaning 8 should have only 1 2, not it cannot have 2 and 3 both. If it has 2 and 3 both, then it cannot be 1 1. It is many to 1. Many to 1 meaning 2 and 3 are many. 1 or more is many. So many, 2 and 3 is many to 1, 8. Okay, that's many to 1. 1 1 says that, the concept of 1 1 says that it should have only 1 in the domain, 8 should have. Meaning that every element in the codomain should have a unique pre-image in the domain. Okay, so what I was saying, this is pre-image, this is image. Image has codomain and this is domain. Okay, we should remember this. Domain, pre-image is the domain and codomain is the image. Okay, so every element in the codomain should have a unique, like the function, definition of function, I'm just giving the just opposite thing. Okay, you should have a unique image in the domain. Simple, very simple. Okay, that was 1 1 and onto, as I said. Okay, so and onto was when there is no elements, and if there are some elements left like 64 125, then it is called into. Okay, if it is not onto, then it's into. Okay, now we know objective. Now objective and subjective is 1 1 and subjective is onto. Okay, so this was simple, and if both is present, then it is bijective. We say bijective. Okay, so that's bijective, and that was a simple thing. And now we understand what is 1 1 and onto. If function can be 1 1, function can be, how can a function be 1 1, and how a function we can say it is onto. Okay, now our next topic that we now would like to talk is composite function. Okay, so now what is composite function? Okay, for as now let's come in the practical life. If there is many things like in this human world, anyone can do cheating and can bribe the not every teacher, but I am just giving an example to stop bribing of teachers. What does board do? Board, to avoid this cheating, what does board do is very simple. They composite function, in normal function there are 2, but in composite it's 3. Okay, if the roll number for you, if my name is Gaurakrishna, I am allotted 13. Okay, board makes that with some function, it's applying some function and making that as 2087. It has applied some function, I don't know what has it done, and this, okay, 2087, and this, okay, now it is now 2087, and now it converts this and it gives to the teacher. Normal to the teacher, and then when the teacher checks this paper, now 2087, it converts 13 2087, and the teacher receives that you have to check roll number 2087. Okay, now if I am a teacher, I would get 70 bundles of paper, and it will be roll number 2087 to roll number 2086, and like that. And I don't know what's the name, what's the everything. Okay, so I only know my roll number is the student knows I am the roll number 13, and the teacher knows I am roll number the student is roll number 2087, and the board only knows what the function was applied. Okay, so as we are talking, okay, so here so 2087, now when the teacher would check that paper, okay, so if I get 1440, that would be checked. Then what would happen? Then the teacher would give it back to the board, back to the middle. Okay, when this board would receive, then it would inverse that function, meaning it knows that what function I applied. So what, like if I applied the function x square plus 1, like my roll number, if giving you an example, if my roll number was 13, then what the board did, it made it 170. Okay, 170. And when this board receives the paper 120, how can it now find out that which roll number does it belongs to, which student does it belongs to? For that, the board what does is, it thinks that what I did square, first I had the roll number square and then added 1. 13 ka square, 13 raised to the power 2 is 169, then added 1, 170. So what the board now would do is 170 minus 1, 169, and raised to the power 1 by 2, and then the board would get the answer 13. Then it would give the student back the paper as receiving the roll number 13. And here we have understood that this is what composite function really means. Now composite functions, if you are thinking that it's studying, okay, this is the domain. Okay, now if in studying this is a domain, this is the codomain. Then after when board is converting, this becomes the domain and this third one becomes the codomain. And after teacher checking that paper, the third one becomes the domain and the second one becomes the codomain, and then the second one becomes the domain and the first one becomes codomain, and then receive the paper. Okay, so that of the middle one, first one, and the second one, third one, all these three sets is having one set is domain and one set is codomain. So if these three sets is in composite functions, it is very much necessary that these three sets should be 1 1 and onto 1 1, meaning for one only one, and no element is left. Then only it's possible, meaning it should be bijective. Then only it is possible. Okay, like here it's shown. If it is x, then it's converted into fx, and then f is again converted into gfx. Now to understand gfx, now how can gfx be converted to fx? So that is, we are in gfx we are putting an sign in g inverse and g can be cancelled. Like we studied in earlier classes that like tan and tan inverse are cancelled. The same way g and g inverse will be cancelled. So we are putting an inverse function g inverse, then it will be fx, and again an f inverse sign, then it will be x. Okay, so now our topic comes to inverse functions. Okay, inverse functions. Now first I will show you algebraically what does inverse functions represent. I was giving an example, y equals to fx, can I write like this? And what I was giving an example was x square plus 1. So y is y x square plus 1, yes, y is x square plus 1. Okay, no, okay, so y is x square plus 1, yes, it is. Now we can be right, x square is equals to y minus 1, yes. Then x is equals to root under y minus 1, okay, yes. Then simply we say now what we are writing, x equal to x in terms of y. So here when we were solving, we got y equal to fx. So we can write f inverse y equal to x. So this is the inverse function, f inverse y is equal to x, and that's the main thing. And this was all about inverse functions that right now we are talking. Inverse functions, as I am also saying, that it's just inversing the normal function, and that normal people do. And first it is converting from gx to fx to gfx, and then inversing it to gfx to fx and fx to x. That's inversing that function. Okay, now now if I started algebraically, now I should prove 1 1 and onto also algebraically. If I need to prove a function to be 1 1 and onto, and I am given that equation, and as I took x square plus 1, The law says states that if fx1, it is given that fx1 is equal to fx2, and if we are able to prove that x1 is equal to x2, then the function would be easily called 1 1. Okay, so I would prove also how and why. Okay, so as I was saying, x1 equal to x2. If x1 is equal to x2, so